Welcome. I'm going to be proving the sum of two even integers is even. But before starting the proof, I'm going to be considering some things that anyone would consider before starting a proof. That is, I'm going to think of this statement in terms of a conditional. And what I mean by that is I'm going to try to identify the hypotheses and the conclusion of the statement. And perhaps even write that down separately in the form of a conditional to give the proof some structure. So I could write the sum of two even integers is even this way. For all integers x, y, if x and y are even, then x plus y is even. All right, there I've got it. Now I've got my, you see, I've got my hypotheses, that is, x and y are even. And I've got my conclusion that I want to make. X plus y is even. So I've given it this statement a little bit of structure. The next thing I want to do is seek out any relevant definitions in the proof. And in this case, the relevant definition would be the definition of an even integer. So I go and I seek out the definition. Let n be an even integer, or just be an integer. N is even if n equals 2k for some integer k. Now here k is just kind of like a dummy variable. In other words, I could have said n equals 2w for some integer w. So as long as k or w or whatever letter of the alphabet I pick is an integer, n will be an even integer. Okay, now I really have the foundation laid out for this proof and I feel like I'm ready to start. I've written the statement as a conditional and I've laid out any relevant definitions for the proof. So let's start. So let's start with what's given. We're going to suppose x and y are even integers. Notice this was part of my hypotheses. We now show the conclusion. That is, we now show x plus y is even. Well, what does that mean? That is, we show x plus y equals 2t for some integer t. Notice I've adopted the definition of an even integer. Cool. Okay, now what do I know to help me prove this? Well, I know x and y are even. So, since x and y are even, x will equal some 2w for some integer w. And y will equal 2q for some integer q. Okay, thus x plus y will equal, well, if I replace x with 2w and y with 2q, I have what you call a direct substitution. So I put my justification over here on the right for that step. Now I'm going to factor out the 2. And that's just using what's called the distributive property. Now I'm going to call 2 times the quantity W plus Q 2T, where T is equal to the quantity W plus Q is an integer. And I know T is an integer because the set of integers is closed under addition. So T is an integer by closure under addition. Okay, nice. I set out to show what I want to show. It's always nice to all have a conclusion statement. This proves x plus y is even whenever x and y are also even. So I restated what I proved. Very nice indeed. And lots of fun too. Thank you.